In the series of experiments of microprocessor, now we see experiment number 8, and the experiment is write an assembly language program for BCD, that is binary coded decimal addition, subtraction, multiplication and division. The instruction that we have for BCD type arithmetic are: one is DA, decimal adjustment accumulator after addition, and other is DAS, decimal adjustment after subtraction. Flags will get affected. Those who get affected after this BCD type instruction are all six types of flags, six conditional flag: auxiliary carry flag AC, carry flag, zero flag, sign flag, parity flag, and overflow flag. We know that BCD is binary coded decimal, means 0 to 9 numbers are allowed. We have 8-bit allowed to convert given hexadecimal number into BCD form, unpacked BCD form. 10 number, which is represented in hexadecimal as 0AH, that number is represented in BCD as 0001, 0001, and 4 times 0. 11 is represented as 0001, 0001. 12 is represented as 0001, then 0010, like this. All the numbers are represented as BCD when we use BCD type arithmetic, unpacked BCD form. Only 0 to 9, up to 0 to 9 numbers are allowed. The numbers which are greater than 9 are converted into corresponding BCD number. Here we are using 8-bit number, so the maximum, the largest number we can perform BCD arithmetic on is 99. Okay, so we'll see how we can perform BCD addition, subtraction, multiplication and division. For BCD addition, we have DA instruction, which can be performed after add or ADC, which convert hexadecimal number represented in stored in accumulator AL register, and that hexadecimal number will get converted into its corresponding BCD number. DAS instruction will be executed after sub or SBB instruction, which convert the result of subtraction, which is stored in accumulator register, into its corresponding BCD value. For example, if the result of addition is 12, that is 0BH, 0CH, then that 0C will be converted into 12H, 12H, when we perform DA instruction after add. That DA instruction will convert the number in hexadecimal into BCD form. How to convert given number into BCD form? If lower nibble is greater than 9, then add 606H into that number. If higher nibble is greater than 9, then add 60H into that number. If lower nibble and higher nibble both, nibble means what? 4-bit group of 4 bits. If we have 8-bit number, then lower 4 bits means lower nibble, upper 4-bit group is upper nibble. Okay, so depending on the value of lower nibble and lower nibble, we can add 6 into corresponding nibble group. And if auxiliary carry flag is set, means the carry is forwarded from upper MSB of lower 4 bit, that is lower nibble, to higher nibble, carry is forwarded from lower nibble to higher nibble. If then auxiliary carry flag is set. If auxiliary flag is set, then we have to add 6 into the lower nibble. If carry flag is set, then we have to add 6 0. We have to add 6 into higher nibble of the number to convert given number in hexadecimal into its BCD form. Okay, right now we will perform. We know how to perform addition, subtraction, how to convert given number into given number in hexadecimal form into BCD form, but the two operations which are multiplication and division, we don't have any special BCD instruction. So we have to perform multiplication by using addition, and then result of addition should get converted into a BCD form. So how it is performed? We know that if we have numbers num1 and num2, and if we want to perform multiplication of num1 and num2, what is the meaning of multiplication of num1 and num2 is num1 should be added to itself by num2 times, or num2 should be added into itself. Num2 should be added itself. Num2 should add itself by num1 time. Num1 should add itself by num2 times, one option, and num2 should add itself by num1 time. By both way we can perform multiplication of num1 and num2. So for that purpose we have a algorithm. We are performing addition of num1 in num1 by num2 times. Addition of num1 into addition of num1 by itself, num1 by num1 by num2 times. Num1 should be added towards itself, added in itself by num2 times. Okay, so CX register is set as a value of num2. AL, which store the value of addition or final value of multiplication, so AL is set as a 0. Add AL comma num1 means 0 is added into num1. Then da, whatever the addition in hexadecimal number, that converted into BCD number. Then decrement CX by 1. The CX value is set as a num2. Now it is decremented by 1. And again, whatever addition performed previously, that addition is stored in AL, and in that addition again num1 get added. So num1 will be added 2 times. Then third iteration num1 will be added 3 times. In fourth iteration num1 will be added 4 times. In fifth iteration num1 will be added 5 times. Suppose we have number 4 and 3, so 4 will be added by 3 times. 4 plus 4 8, 8 plus 4 12, means 0 plus 4 first time, then 4 plus 4 8, and then 8 plus 4 12. Otherwise 3 will be added by 4 times. 0 plus 3 3, 3 plus 3 6, 6 plus 3 9, and 9 plus 3 12. This is very simple program to perform BCD addition. We have to perform addition, and after each iteration we have to convert the result of addition, which is stored in AL register, into BCD form. See the example. CLF register, we have a DB type num2, so we have to use CL. CL is set as a num2, you can see here. Then AL is set as a 0. First addition is before adding number num1, we have to set AL as a 0. Then add AL comma num2, 0 plus num1, that is 5. Then that result is converted into BCD form. Decrement CX by 1. If CX is not 0, JNZ, If 0 flag is not set, then repeat the block T. What is that block? Addition of AL, whatever the content of AL register, and num1, means 0 plus 5, 5 plus 5, 10. 0a will be stored, 0a, 10. 10 means 0a, and 0a will be converted into 10. By which instruction? Die instruction. Then 10 plus 5, 15. Actually, the result will be 0f, but 0f will be converted into into BCD form, that is 1 5. That is 1 5. Okay. This is how we can perform all the operations, and at the last we'll get 20h. The result of the multiplication is 20h. Okay.
As we have seen in the previous slide, that is we can perform BCD multiplication by using result of addition. By we have already seen the result of multiplication, num1 multiplied by num2. Now we'll see how we can perform a division operation by using subtraction instruction. Because we have only subtraction instruction, we don't have any division instruction to convert result into BCD form. So here we are actually performing a subtraction operation, and by using subtraction we are performing division. So suppose we have num1 and num2. Num1 should get divided by num2, and we have to find q, that is quotient, and r, that is remainder. So actually we are performing subtraction operation. How? So if we have 8 and 3 numbers, and 8 should get divided by 3, so then we have to perform subtraction, that is 8 minus 3, that is 5. If 5 is greater than 3, then again subtract the result of subtract 3 from result of subtraction, that is 5 minus 3, result is 3, result is 2. Now result of subtraction is 2, which is less than num2, that is 3. So here we have to stop performing subtraction. How many subtraction we have performed? We have performed 2 number of subtraction. And what is the last result of subtraction? That is 2. So 8, if 8 is divided by 3, then what the result of subtraction is, or the quotient of subtraction is 2, and remainder of subtraction is 2. So we have to first compare whether num2 is less than num1 or not. If num2 is greater than num1, in the first comparison, if num2 is greater than num1, then obviously quotient will be 0. Subtraction we have to perform if num2 is greater than num1, and the num1, whatever the value of num1, that will be the remainder. And if num1 value is greater than num2, then we have to perform subtraction. We have to increment q by 1, and we have to compare result of subtraction with num2. If the result of subtraction is again greater than num2, then again we have to perform subtraction. Subtract num2 from the result of subtraction from previous subtraction, and this process continues up to we get the result of subtraction is less than the num2 value. How many number of times we are performing subtraction? That is nothing but the quotient. And what is the result of last subtraction? That is nothing but remainder. So as you can see in the algorithm, data segment will be initialized. Num1 is transferred to AL. Compare AL and num2, means num1 num2 comparison. If in the first comparison num2 is greater than AL, then stop performing further subtraction. Otherwise increment. If num1 is greater than num2, then increment q, subtract num2 from AL, result is stored in AL, and go to step number 4. What is that step number 4? Result of subtraction which is stored in AL compare with num2. If the comparison result num1 result of subtraction is greater, then again we have to increment q and again subtract further. Otherwise, if the result of subtraction is less than num2, then we have to stop there. This is how we will get result of division. It is the program. Here we have program that is num1 is 8, num2 is 3. So as you can see in the code segment, num1 is transferred to AL. Then comparison, 8 is compared with 3. 8 is greater than 3. No sign flag will be set. 8 minus 3. Okay. No change in AL register. Only comparison instruction is used. So sign flag is not set. So increment q, subtract. Here we have to subtract. 8 minus 3, 5. Result is stored in AL register 5. Then again compare AL with num2. 5 is compared with 3. 5 minus 3, 2. Result positive. So now sign flag again will not set. Increment q is now 2 and subtract 5 and 3 means 5 minus 3 result is 2. Result is stored in AL. 2 is compare AL result is 2. 2 is compare with 3. 2 minus 3 result negative. So sign flag is set. Now we got a reminder as the result of last subtraction, that is 2, and q is incremented by 2 times. So q is 2. 2 is the quotient and 2 is remainder. This is how we got the result of division. And after each subtraction, we have to perform DAS instruction to convert subtraction result into BCD form. It is the result of addition.
For BCD addition, we have DA instruction which can be performed after add or ADC. 3 results. Multiplication, 7 into 4, AL register. You look at the AL register, 28. Then result of subtraction, 7 divided by 4. 2 is quotient, and 1 is remainder. 2 is quotient and 1 is remainder. You can see. Sorry, 7 divided by 4. 1 is quotient and 3 is remainder. So you can see 1 is quotient here and 3 is remainder. 7 by 4, 1 is quotient and 3 is remainder. Exercise question asked for you. AL value is 99H. It is converted in corresponding binary value, so that you can simply observe what is the content of AL. Then BL value is 01. Then add AL comma BL. So 99H plus 01H, you can see the addition. Addition is 9AH. 1010 means 10, that is 9AH. Here you can observe that lower nibble is greater than 9. So add 6 in the lower nibble. So 9AH plus 06H, the result will be A plus 6. 10 plus 6, 16. 16 will be represented as 10H. 0 and 1 is carry. So 9 plus 1, 10. 10 is represented as A0H. Again you can observe A0H. Here again higher nibble of the result is greater than 9. So we have to add 6 in the higher nibble. So A0 plus 60H, result will be A plus 6, means 10 plus 6 is 16, that is 10. So carry flag will be set. Carry flag is equal to 1, and the result of AL register will be 00. result of AL register will be 0 0 and carry flag is set, means result is 100H. 99 plus 1, result is 100H. Again one example, AL register content is 03, you can see in the binary form. BL register is 07 and we have to add 3, we have to subtract 7 from 3. Result will be -4. How it is converted into BCD, we can see. If we use die instruction, then what happen? If we use die instruction, AL is equal to AL minus BL, 3 minus 7. How we can get the result? 111 1100. You can see, you can observe the MSBTE is 1, so this result is positive. But if we use a die instruction here, then we can add 06. We can add 06 because lower nibble is greater than 9. So, and also you can see auxiliary carry flag is set and carry flag is also set, because after this subtraction you can see carry flag is also set and auxiliary carry flag is also set. So add 6 in lower nibble also and in higher nibble also. So 9A plus 6H, what will be the result? 1008 if we use die instruction. But we should use which instruction after subtraction? DAS, so that we can subtract 6 from higher nibble also and 6 from lower nibble also, because carry flag is set also and also auxiliary carry flag is also set. So we have to use DAS, but here we are asked to perform right instruction DA, and what will be the content of AL? So we have to get answer as 100H. So this is how BCD addition, subtraction, multiplication and division take place. BCD multiplication means num1 should be added to itself by num2 time for performing multiplication, and for BCD division we have to perform by subtraction. Subtract num2 from num1, and if the result is not less than num2, then again subtract num1 from num2 from num1, and this process continue up to the result of subtraction should will get less than num2. So how many subtraction we are performing, that is nothing but quotient, and what is the result of last subtraction, that is nothing but remainder. This is how we are performing BCD multiplication and BCD division. And straightforward BCD addition is die instruction, straightforward BCD subtraction is DAS instruction. So I hope you understood this. Thank you.